Alright, welcome to the AP CSA review for the last minute, just for a cram sesh. No, this is not everything that you need to know, but this is the good majority of it. If you don't understand a topic that I talk about here in this video, I'd recommend you just look up a quick tutorial as they're quite abundant and you'd probably understand them a little bit better. Alright, first on to some basic stuff you should know. So these are just some of the data types that these are the data types that you have to know for the AP exam. So you have your ints, which store integers, pretty simple. You have your doubles, which store decimals, so you can have 1.1, negative 1.1 inside of doubles. And then in booleans, you hold true and false values. So these are your three primitive data types. And now you have your string, which holds strings of characters, basically like text. It holds text really. Okay. Now on to initializing some of these variables. So basically, whatever the name of the data type that you want to use. So int here, let's say we're using int, and the variable name is you want the variable name to be called n. So you have how you initialize it is basically int n equal to whatever you want it to be. So it can be equal to another int of that same type, or it can be equal to integer itself. So int n is, say you want it to be equal to 5, so int n equal to 5. Or you can also, in most instances, you can just initialize it and then assign it a variable value sometime later on. So you can just put data type, so int n, and then you put your semicolons. For strings, it's the same format, except when you're giving it a value, unless you're taking it from the same a variable of the same type, it always has to have the semicolon, not semicolon, um, the quotation marks, and then stuff whatever you want inside. So now the stuff inside that those these quotation marks will be assigned to that string variable. That's basically how you do it. Okay, so operations. Please just know maths. Otherwise, I don't know why you're here. But regardless, so you need to know your plus, minus, multiplication, and division. The mod operator, which is basically looks like the percentage sign, basically prints the remainder of something. If the digit is less than if it's less, if the digit is less than what you're than the thing that you're trying to find the thing that you're dividing by to find the remainder, then it just returns the number. Okay, quite simple. So then you have your plus equals to. This is just your value plus whatever you say. So let me just explain this a little bit better. So you have num plus equal to 5. Say num is equal to 5. So you end up with what the new value for num would be is num plus 5. That's the new value for num. And this applies for minus equal to, so that would be num minus 5, and times equal to num times 5. Basically, it goes on for all of these operations. Then you have your increments. Basically, they increase or decrease by 1. So plus plus increases by 1, and minus minus decreases by 1. Okay. Also, for your plus signs, these can be used to join two strings together. So say you're initializing something, and you initializing a string, and you have two separate sets of text that you want to join together. One is parenthesis, these quotation marks stuff inside, and then the other one is the quotation marks hello world. So how would you do that? It's using a plus sign in between them. That's basically, and then in the end they'll become one string. That's basically what that plus sign does to strings. Okay, so these are your three error types that you need to know for the exam. You have your syntax errors, which basically are just like spelling errors, some errors in the physical typing of the code itself, nothing logical or such. Okay, so here are just some examples. A spelling error, you forgot to capitalize something, or you forgot a semicolon. That's what a syntax error is. An exception error is the time when you attempt to divide a number by 0, which is not possible, so that throws out an exception error. Then you have a logic error. So like the code works, but there's an issue in the actual logic. So like instead of using a plus when you're trying to make the sum of two numbers, you use a minus. That type of stuff. If you want some clarification, just read over these detection. Okay, So these are mainly used for strings inside of strings. Basically, um, if you're trying to have a tab inside of a string, you put this in there, a slash t. If you're trying to insert a backspace, you put this. If you're trying to start a new line inside of one string, then you use the end. You really won't be seeing these a lot on the exam. They're just here, so you should probably know the first three and the last three. Just look over these. Just keep them in mind on what they do. Okay, they're really straightforward. So typecasting. So say you have a double that you want to interact with an int variable. So say your double's name is n, okay, and it's equal to 1.1. So using this structure, basically you have the whatever you want your variable, whatever you want it to be returned. So you say you want your double to turn into an int just for that line. So basically what you do is you typecast it. Basically you put the parentheses and then whatever variable you want it to be. So your var, say it's equal to 1.1. Now var is now an int just for that line. Just remember, just for that line. It's not permanent. So that var, and it's only in this instance. So you can use var on that same line, and it'll be a double. You have to always typecast stuff. So basically, what would happen here is this var would now become int just for okay. And what happens in an int? Ints can't have decimal places, and note Java always rounds down. The 1.1 will be turned into a 1. Okay, remember that. So you can go from an int to a double. When you're going from an int to a double, it just adds adds 0.0 to the number. That's pretty simple, and it doesn't work for all primitive data types. Like you can't turn a boolean into an int, which as far as I know. All right, so now on to the main thing. You should probably start paying attention here. Objects and classes. So Java is basically an object-oriented language, and basically what's happening here is objects. Basically, they basically are the things that we use to perform things in Java. And a class is basically the blueprint for objects. So basically, it doesn't apply. They're logical entities. They composed of the names, attributes, and methods of the object. They basically define the object. Okay, and objects are like the physical thing that you utilize here. Okay, so here we see class declaration. So first, whenever you're trying to write, this is mainly for the second FRQ. You have to know how to write a class, at least for this year. Basically, you put your public keyword, then you have your class keyword, and then whatever you want your class name to be. All right. Then you have some variables. Remember, they always have to be private. Okay. So private basically means they cannot be accessed outside of that class. Remember that. So you have however many private variables you need, and they basically are used throughout the class, and they can be used in every single method. Basically, that's how you check if you need to have these private variables. Okay. So then you have your constructor, which you see with the public time over here. This constructor basically allows you to construct objects. It's the method that allows you to construct objects, and always has to have the same name as the class. Okay, so you public time, and then whatever variables you need to have. These are the parameters. They happen within these parentheses. These are the parameters, and then here you see this is the main constructing part. It basically allows you to access and change these methods, change these variables from outside the class. And it just assigns values to these. So this HR, say h is equal to 2. So now this HR will be equal to 2, and same with min. Okay. So here we see some methods. Here's a get method. It basically allows you to access it basically allows you to see and access these variables. The get methods allow you to do that. Then you also have set methods, which basically allow you to set a new value to these private variables, but through methods, since you can't directly change them outside of this class. Okay. So main two methods that you need to know are get methods and set methods. Basically, set methods set a new value to these private variables from using a method. Okay. So moving on. So here we see a little bit more in depth into a method declaration. So you have your public keyword. Then what does static mean here? So static basically allows you to whenever you're calling a method, you usually have to use the object's name, whatever object you have, dot, then that method's name in parentheses, and whatever parameters you have to have inside those. Well, static allows you to not have to call upon an object. It just the method's name, parentheses, and parameters, and that's basically calls that method. When there's nothing here, when there's no static at all, it basically then you have to use that object. You have to use the object dot and then your method call. Okay. Then this int is your return value, the thing that returns. Remember that returns whenever you're returning something, it immediately takes you out of that method or a loop or whatever. Okay, so it returns basically what you're going to be returning, what type of data you're going to be returning, and this applies for objects too. So you get or strings and basically anything. You can have booleans being returned. So you have method name. So you have an add method here. Then your formal parameters. Okay, then you have whatever you need to have in the body. Okay. All right. This is the Java quick reference sheet. This will be on the exam. Here we see a couple methods like the math class. You should math class and the string class. Basically, this allows you to transmute strings and do things to strings. The string method is pretty. String class is pretty straightforward. So and this works for the string data types that we were talking about. That's what the string method is used for. Okay, so you can make a substring or find the index of something inside of a string. So just look over this, and this will be on the exam. Just remember that. The integer class and double class are basically just they're just equivalent, the class equivalents of the int and double data types, primitive data types, and they also work. So don't pay too much attention to these. You might see them once on the exam. Just keep them in mind, and they will always be on the API sheet. Okay. So here we have your math class. So math class again is pretty straightforward, except for the last one, the math.random. Remember all of these are static methods, so you don't have to for at least for the math class you don't have to refer to some object. But yeah, for the math.random, it basically returns a random value between 0.0 and somewhere less than 1. But say you want to return, you want a value that's between 1 and 10. How would you do that using the math.random? What you do here is, so you multiply math.random, the method, by the range, what the range would be, 1 minus 10, say for the what we're talking about. So 1 minus 10 would be 9. So you would multiply that by 9, and then you add. So what you do here is you multiply math.random for your range, and then you add your min value to that. Remember that. So that basically allows you to get any random numbers using math.random. So what you do here again is you multiply the random by range, and then you add your min value. Okay, remember how to do this. Then you have your array lists. We'll talk about these later, but just keep these in mind. These again are pretty straightforward. We'll get back to array list later. And then very last one, very last two. So this dot equals is we'll also talk about this later. So keep this in your back pocket. And then here we have your toString method. Basically, you should know how to write these. It basically converts any your variables into. It basically prints out a string for you. It converts your variables into strings and then prints them out. Basically. You might see this once on the exam. Okay, now on to loops. So basically, your loops are pretty standard. You have your while loop, which basically says while this is true, you have while the condition is true. So we'll talk about those conditions later. The body of the loop will happen, and then you have your updatation somewhere in this whole body. It can come before the main meat of the loop, or it can come after, or somewhere in the middle. So basically, the one perk of while loops is you can update it midway through the loop or whenever you want to. Okay. So you have your for loops, basically where you initialize your value. You have to initialize something inside of that. then you have your semicolon, then you have your condition, and then you have your updatation. So basically how this works is you have, say, you initialize n is equal to 0 inside of that loop, and basically that means n can be only used inside of that loop. So you have n, and that condition basically is, well, that this will only happen, the loop will only happen while this condition is true, and then your updatation always happens after the body of the loop is executed, okay? So the updatation always updates your initialization. Remember, you must always have an updatation, otherwise your loop will run off forever. And then you have your one last type of loop, your for each loop. Basically, you initialize something, and then you have this colon. You basically have your colon, and then you have some array. So basically, this allows you to traverse through the array without going over the length of that array. So, and it basically does, basically it goes through the array, and for every value goes through the array, it assigns whatever data is on at that instance to the name. So say you have an array list names that has Regina, Steven, Dave, and Marsha. It'll go through. So first iteration, name is equal to Regina, and it prints out Regina. Then next iteration, name is equal to Stefan, and it prints out Stefan, and so on until the loop, until the array just ends. Okay, on to Java Boolean conditions. So here's stuff you should know. Remember, conditions are Boolean values. While the loop will run, or the if statement will run while the condition is true. You have your double equal sign, which just states equal, which that's how equals works. Then you have your and, double 2 ampersands, which means and. Both things must be true to return true. You have your or, which is two vertical lines, and basically only one must be true to return true. And then not equals to, they must not be equal to return true, and then no not just reverses whatever value you have, whatever value you're gonna get. Okay, then talking about the dot equals method, just pull that out of your pocket now. Basically, it's the equivalent for the double equal signs, but for strings only. Okay. Also remember, you in Java, how do you show your greater than and less than signs pretty normally, just greater than and less than. But say you want to show greater than or equal to, or greater than or less than or equal to. What do you do there? You put your greater than or less than sign, and then you have your just one equals. Okay. So how would you show that? Greater than and then equals. Okay. Just look at these truth tables just if you want to get a bit better grasp, and here's some practice problems if you want some. Okay. So talking about if statements. So if statements basically pretty straightforward. If the condition is true, then this will happen. Okay. So say if this value returns true, then this statement will happen. But what happens in the case if this value is not true? Then it will go to an else if or an else statement depending on what's going on in the method. So in this case, it has an else if statement. So else if the condition is true, then it does this. And then you can have as many else if statements as you want inside of one condition sequence. So so here, if this is true, but say this is false, then you'd move on to the second else if statement. And if that's false, then you go to finally you end up with your else statement. Okay, which basically states that if all three of these things are not true, then this will just happen. Pretty straightforward. If you look here, this is the initialize, how you do the else, if, else, and else if statements. Like, this is how you do them. There's also another way to do them, which is just for one line issues, which is basically you have your if, you have your condition with the parentheses and such, but instead of having your curly braces, you just have that one line of code that you need in that, and then you just have your semicolon. That's it, and that's how you do just singular else if and else and if statements. Okay. So here are some the De Morgan's laws. You should definitely know this. It's basically this distributive property of logic. So say you have a statement like P and Q over here, and if you want to factor the not into the whole thing. So what happens is the not is applied to each variable, and then this is the rule for De Morgan's laws. The ands become ors and ors become ands whenever you're applying this. So the not parentheses P and Q evaluates to P naught or Q naught. And the same applies for vice versa. So you're going from not parentheses P or Q, it evaluates to P naught and Q naught. Okay? Here's some more truth tables just to get a better grasp on this. Okay? So this is your double loop statement. Basically, the thing you should take away is the first loop would first it'll iterate once, then it will go into the second loop, iterating however many times it needs to. Then it goes again for a second iteration of this loop, and it again this one iterates another time for however many times it does, and it keeps doing this until this condition is met. Okay, and basically what happens in the end, to find the amount of total iteration to happen is you multiply the amount of iterations for the outer loop and multiply with the inner loop iteration. So this would so the total amount of iterations would be 15, and you mainly use this for your 2D arrays. So keep this in your back pocket. So now onto arrays. They use dot length to find the length and have no parentheses. Remember that. Have a set size and cannot grow or shrink. And basically to access or change any values, you just put the array name and then equal to whatever value. This is like the equivalent of a set method. So now the value at n is equal to 3. Okay? So this is how you declare an array. Just for the sake of time, we're going to keep this short, but here you have your type of array. So you can have a string array, you can have a double array, you can have a Boolean array, an int array, and then with your box brackets, then the name of the array, and then new int and the length. Okay? Then there's another way to declare it. It's the same as this, but say you can put your curly brackets and then the amount of the initial what values you want stored in there in this format. Okay, so and remember, also recall, just I'm saying this pretty late now, but remember for strings, arrays, array lists, and 2D arrays, all the length will be just start from 1 to however long it is, but the actual index of the values will always start from 0. So here the index of 1 will not be 1, but it will be 0, and then you just keep counting from 0. So just whenever you're traversing through an array, always remember either you use array name or string name, whatever, array name dot length or dot size, depends on the name, depends on what it is, but -1, or while you're traversing, use just the less than or greater than sign, and then array name dot length. Okay, so moving on, now we have your array lists. Remember, again, these guys start from 0, the index starts from 0, but the actual length in this case size starts from 1. So just before we go, say you just before we go fully onto array list, say we have your say you just want to get the value at n for my ints. So what you do is just forget with this equal sign, you just put my ints box brackets n, and what will happen, it will just return the value at n. So say n is equal to 2, so 0, 1, 2, and it will return 18. Then that's basically how you get the value, any values in the arrays. Okay, for array lists, you see here, this is how you declare them. Okay, this part's a little cut off here, but you have your array list keyword, then you have your greater than less than signs. Inside that you have the type of array, what data type you want to store here. You can store objects, you can store primitive data types, whatever you want you can store in here. A string in this case, and then whatever name you want it to be, and then new array list, again this thing, and then parentheses, semicolon. That part's cut out. Okay, so here we have some straightforward methods. You have your add method dot add, which basically adds that to the very end of this array. Okay, get method, and then whatever index you want basically returns what the value is at that index. You basically remove something, whatever at the index, and then you have your size method, which basically starting from 1 will return the size of that. Okay, remember size, length, and length methods always start from 1, while the actual index always starts from 0. Okay. There's some more methods on the Java API sheet. Just look over them. Okay. There's also another way you can initialize array lists, which is you have your curly brackets and then the values you want stored in there. So just like in an array in this case. Okay. Moving on to 2D arrays. One of We're almost there, guys. So basically, initialize 2D arrays pretty similar to your arrays. You have your int array, the array name, and then when you're initializing it, you put the type of data that you want. You're gonna be objects again, primitive data types, whatever. You have your two box brackets. Remember this: two box brackets, the name of that array equal to new keyword and the type of array that you want. And then inside of then you have your two box brackets. And then you put in the first set of box brackets, you put how many rows you want, and then the second set, you want to put how many columns you want. Okay. So just basically it creates the second one here creates 10 rows and 2 columns. Also, you can initialize your values to an array here in the same manner to arrays or array list. You have your curly brackets, and then you see this whole string of characters here. So what this is the row. So for each one of these inner curly brackets is just the row. Okay, so in row 1, or in this case, it would be row 0, since arrays always start from indexes start from 0. So in row 0, the values would be A, comma B, comma C, comma D. So that's in one row, and then in the second row it'll be E, F, G, H, and so on. I hope you got that. So and this is how you let's recall the let's just recall how you traverse through a 2D array where you have your double loop system. So basically, you can either do it with rows first or columns first. It really doesn't matter. But basically, what happens here is if first you traverse through the first you go to row 1, and then you go through each column. Then do whatever you want to do for that, and then go to the second row and you traverse through each column, and so on. Okay. So that's how you do your 2D arrays. So remember, 2D arrays use dot length with your parentheses. Okay. Your rows are dominant, basically meaning that they come first, and then columns usually are columns come second. So you have your array dot length minus for the number of rows, index of rows, and then array box bracket whatever row you want, column you want, dot length parentheses -1 for the index of columns, not number, index, sorry. And you traverse them through a double loop system. Okay, on to inheritance, something you'll never get. So basically you show inheritance by using your class name extends your whatever parent class you want. So what really is inheritance in Java? Basically, inheritance is basically states that is a relationship. So basically, cat is an instance of animal. It's just cat has a couple extra methods that animal cannot access, or has different methods that animal can't access. Basically, but cat can access the methods that are in animal. So let's clarify this a little bit. So say animal has a get method, and cat has a set method. So basically, cat has access to animal's get method along with their own set method. It basically, you don't have to rewrite all of the methods that you have in one class, in your parent class. It's automatically extended to your your student or your student class, or whatever class or whatever you want to call it. Regardless, say you have in cat, you have another different type of get method. Say it does something slightly different compared to animal's get method. So, and you have a cat object and you call it. So what happens here is it will always prefer the cat version of the get method, not the animal version. It overrides it. Okay, remember overriding methods as you see here in step 8. Okay. So remember, in Java you can't have multiple inheritance. There's subclasses and super classes, and code reuse. Okay. Remember, how would you declare a class? I believe we have this on the next line. See here, child extends parent, and it has access to all of parent's methods. Okay. So, what does a super keyword do? This is one of the most important things you need to know. Super can be used to refer to immediate parent class instance variables. So, say you have super allows you to access the instance variables in animal. Basically, since the instance variables cat can't access the subclass cannot access the instant variables in their parent class. Remember that. So, super allows you to access the things in your parent class. Okay, super can be used to invoke immediate parent class methods. So basically, just using super dot whatever. Say you want to access the show method here that both classes have different versions of. Super dot show. Basically, this allows you to move up to the move up to and print out the parent version of that method instead of printing out the child version of it. Then the final one is super parentheses can be used to invoke immediate parent class constructors. It basically allows you to just uh, basically just immediately invoke this using depending and how does it and how and it just put super parentheses and semicolon and it'll just do the method for you. But you might ask, how does it choose what method it wants to do? It decides it upon the parameters. So say you have a show method here that say has the parameter. You have two versions of the show method in parent. Which one that has int and the other one that has two ints, say two parameters. So and then you call upon it in the you call upon it here with one int. So it'll basically decide to immediately do the show method with only one int. Okay. Say you have two ints, it'll decide to do the show method with two ints. Pretty simple. But this super method doesn't work when you have multiple different method names that have the same type and amount of parameters. Okay, so just keep that in mind. So remember, constructors cannot be inherited, but methods can. And this is how you call your super. Using the super keyword, you can call superclass and just access anything in the upper class. Okay. All right. So polymorphism. What is polymorphism? Okay. Polymorphism is basically having multiple parents. Having multiple parents. So basically, what happens in polymorphism is, say you have a parent. You have a parent object that's called, I don't know, call parent call, and then instead of doing new parent, you do new child. So what happens here is basically parent has access to child's methods only if the same methods are in the actual parent class. So basically, this gets a little weird here, but say a child has an extra method called get, but parent doesn't, parent can access that get method. But since parent also has show, and child also has show, it'll use the show child version of show instead of parent. So basically, what happens here is the amount of methods and the type of methods depends on child, and then and then sorry, and then you have your and then the amount of methods depends on parent, while the amount and type of methods depends on parent, and while the what the actual thing that happens in those methods depends on child. So just to recap, what happens here is parent must have the same methods as child for those methods to work, while it always performs the child version of those methods. Okay. Also, last thing before we move on to the next topic is that you cannot say you have a class, you animal, and you have animal cat, and then you have another class that extends cat. You cannot immediately access the grandfather version. You cannot immediately access the grandfather class or animal, because that's not how Java works. You have to go through cat, and then say you have a method that lets you act in cat that lets you access animal. That's how you go through that. You cannot immediately access animal. Okay. Now on to recursion. So, okay. So recursion basically, recursion just continuously moving through something. Okay. So basically, how recursion works is you inside of one method you call upon that same method again. So say you have your Fibonacci sequence. Um, Inside of the Fibonacci method, it calls upon the Fibonacci method itself. So it basically performs this one method over and over again until the base case is met. Well, what you might ask, what is the base case? Well, it's a thing that basically ends that recursion sequence. Otherwise, it will keep going and going. So that this base case usually works in the form of some sort of if or conditional and then a return statement. Okay. But yeah, recursion are pretty simple. They basically just perform the stuff that happens in a method over and over again. So say okay, and remember when you're doing the recursion on MCQ, always remember to write it out. Otherwise, you'll most likely get it wrong. Since the logic is pretty simple, it just there's so many steps that are happening. So just always write it down, and you'll get it 99% of the time. Okay. So now talking about insertion sorting. So what does insertion sort do? Um, it basically goes through and finds the smallest value and then moves it to the front, and then it'll subtract the array length by one and start from the second value in the array and check to see what's the smallest compared to that, and basically moves them to the front over and over the front. So basically here, this is like the standard code for an insertion sort. I recommend you probably watch a video on this, but basically what happens here is saying that you're initially this is what the array looks like, and then first pass, you see, okay, 1 is less than 23, so you move it to the front. And then you start from the third value, and you see, okay, 10 is less than 1, but greater than 1, but less than 23, so you move it in between them. Then you say, oh, it seems that 5 is greater than 1, but less than 10, so you move it to the front again. And then in your fourth pass, you basically do the same thing, but for 2. So basically, you go through the array, find the smallest value, and then you move it to the so-called front. Okay. Now on to selection sort. So selection sort is really simple. Is more simple actually. Basically, you go through the array and you switch values to make them order. So this is what the array looks like initially. So you see, okay, a 3 is less than 21, so that's fine. We don't have to switch them. But but say 6 here is greater than 21. So 6 is less than 21, so you switch them, okay? Then you have 15 on your second. 15 is less than 21, okay? So basically what that means is now you have to switch them. And then here it keeps on going. You keep switching values until your array is now ordered, okay? Now on to the final type. You don't really need to decode this, you just need to identify it. Basically a merge sort splits up an array over and over again into smaller chunks and then adds those chunks back together in order. So here you have 53 and 13 and 43 and 10. This is one array. You split that array up into smaller chunks. You split it again into chunks of 1, and then you add those chunks back together in order. So now first go around of merging it is 13 and 53 and 10 and 43. So now you merge them again, and then you end up with 10, 13, 43, and 53. So this is just the basic code of this. You might want to look over this, but you just need to know how to identify it and see what it does and how many steps it really takes. Okay? Finally, on to searching algorithms. Searching, this is your sequential search. It's quite straightforward. It goes through the array or array list or 2D array and just searches through every single value, checking to see if it's equal to it, one by one in a sequence. Okay? And for both of these following searches, sequential search and the other binary search, they have to be in order. Remember that the arrays have to be in some sort of order, especially for binary search. Sequential search, actually they can be in any order. Okay, they can be jumbled up. It just works whatever. Sequential search is just better. Okay. So you have basically it goes through the array, checking to see if it equals the target, and if it is equal to the target, it returns the index. Otherwise, it keeps updating the index, and say the target's not even in that array, it just returns to -1. Okay. binary searching algorithms. Okay, your binary searching algorithms. Just look over this really. It's basically you find your mid value. You check to see if the value at the middle of the array is greater, if your target is greater than or less than the mid value, and then basically you keep on shrinking your search window until you find that. So basically say, okay, my value is less than the mid value, then the new searching area would be from the beginning of the array to the mid value, and say the new mid value, the target's greater than the new mid value in between that searching area, then the value would be, then you shrink the searching area even more until you basically find the mid value until either the mid value equals to the target, or you can't find it in the array. So just I actually for this one, binary search, it's an easy concept. You could probably find a 3-minute video. But regardless, if you don't find it, it returns 1. And for binary search, remember, it always has to be in order. The array list, the searching area has to be in order. Okay, now on to commenting. Okay, the last thing. So you have your 3 types of main comments. You have your single line comments, the double slash. You have your multi-line comments, the slash times and star. Then you have your document comments, the double star, yours, and then you have your row of stars. Basically, this just allows you to comment. You might see a couple questions on the exam. Just remember what these do, and to check to see whenever you're looking for errors, remember to take in the fact that comments exist. Okay. Finally, we're to the end. Okay, so just stuff to know. Remember, always take your time on this, the AP exam, because it's 90% logic, especially for the MCQ, and you'll get the answers, and the questions are relatively easy if you actually take your time and look through the questions. You have an hour and 30 minutes for a good amount, not too many questions, at least for that amount of time frame. So you can just make sure to go through each question, check to see if you're right, double check, and once you're done with the MCQ, you're not done with it. You have to go and double check every single one of your answers if time permits you. Okay? Just make sure to take your time and actually think through each question, because the logic is pretty easy as long as you have a sharp eye. Okay, the FRQs relatively have the same logic. For FRQ1, it's pretty easy. Only loops, no arrays, really. It's just very simple code. FRQ2, know how to make methods. I know I sped through the method declarations, so I'd recommend, again, to watch some sort of video and know when and where to use private methods. Remember, private methods, they basically allow you to use, it basically prevents you from accessing or using methods or variables outside of that class. For arrays and array lists, know how to initialize and traverse these array and array lists. And then FRQ4, just please send hopes and prayers. I'm just kidding. It's pretty easy again. It just know how to initialize an array and traverse them, and how to modify them and all these things. So just keep those in mind. Smart kids, remember, just before I say the last word, I almost forgot something that I missed. Back to the very first slide, guys. I'm so sorry. So here we have, did I talk about final? I might have. But regardless, just to recap, the final, you might see this once or twice. What final means is basically this initialization statement. If you see this, like, say you have data type name and your data type's int, and then you have the variable's name is n. Basically, if you don't want that variable to be changed, just in general, you can put final int and then n. So basically, that means that data type cannot be modified or changed. That value is constant. So say you assigned n to that value. So you assigned 5 to that value. 5 will be the permanent value of that data type. Okay. So, guys, that is our review for AP CSA until this is all outdated by next year. So, guys, just remember, smart kids double check their work and take time. So, guys, let's please be smart. I want to see everyone get a 5. Even you. Okay, so guys, happy coding, and may the AP credit ever be in your favor.